redesigning aeroplanes, the passenger pods hurtling people through tunnels.
Yes! Yeah!
And fancy a flying car? Coventry was once the heart of British automotive manufacturing, dubbed Britain's Motor City, but it's moved with the times. Now hosting the Institute for Future Transport and Cities at Coventry University, playing an important part in the future of autonomous, sustainable and connected transport. And in a city where the first ever British car was manufactured, research has moved to the next evolution of the automobile, the autonomous vehicle. For a few years now, we've been told that driverless cars are just around the corner. And on this programme, we've taken a few for a spin. But before they can truly become a reality, we need to know that we can trust them just as much, if not more, than a human driver. And if this driverless world comes about, it will be transformative, not just for the drivers, but also for the cities. So we may need to rethink some of the basics. We're used to a lot of congestion on our roads, but it seems here like this model of autonomous vehicles seems to actually overcome some of that congestion.
So we know that people spend a lot of time driving around cities, creating congestion, looking for parking space. With fully autonomous parking, you need fewer spaces. So that'll reduce the requirement in infrastructure and in cities for the real estate needed for parking solutions. The vehicle will literally drive itself into a car park, find its spot, recognise the white lines and pull in and park itself.
Clearly the technology has come a long way, but before our streets can be filled with autonomous vehicles, the companies need to figure out how to train them. And we as a society need to be confident with the rules and the choices that we allow them to make. Zoe Kleinman's been finding out more.
This is what we were promised. I took a ride in this truly driverless car from Russia around the streets of Las Vegas last year. It was both terrifying and weirdly underwhelming. Turns out the car was a much more sensible driver than most humans I know.
It took me 3 attempts to pass my driving test. None of it was my fault, obviously. But perhaps I should have come here to Cambridge, where the tech firm Five has developed a sort of driving school for driverless cars.
Five runs endless simulations to ensure that driverless car tech responds safely to challenges on the roads. One small scenario has nearly 500,000 possible variations. Like me, our virtual car doesn't pass every test first time in the simulation. Any driver will tell you it's those unusual moments on the road that you weren't expecting that pose the most danger. A kangaroo runs out in front of you. What? It's happened. It prompted the firm D-Risk to create the world's largest virtual library of edge cases.
We are creating the first true driving test for autonomous vehicles, and the idea behind it is when autonomous vehicles are arriving in the UK, how will the government know that they are safe for UK streets?
But getting the data to build the library hasn't been easy because people don't tend to report near misses.
We've had stories of people driving around roundabouts and seeing somebody take the wrong turn and driving along the motorway up the wrong way. One individual described an experience of having sheep appearing from nowhere as they're turning around a corner.
This driverless car is like a bit of a hive mind. There's a fleet of them currently driving around London, clocking up hours and hours and hours of experience, which they then all use in order to make them better drivers.
London-based Wave doesn't actually make its own cars. Instead, it builds the brains for others.
We're not going to get there by taking technology from 1 or 2 decades ago and trying to commercialise it with brute force and billions of dollars of capital. Things like machine learning, this is the technology that's going to power the future.
Wave's idea is that its cars record their journeys, share their data with a central HQ, and the useful bits feed into its learning and then back out to all the vehicles with its brains in their boots. Try having a go at the Moral Machine, a game set up by MIT scientists to explore how humans think driverless cars should react in various scenarios. Warning, they're all horrible.
Oh, this is just awful.
You saw examples where people were willing to sacrifice poorer people to save richer people, or heavier people to save more athletic people. What I would consider to be immoral, yeah.
Fortunately, none of us is in charge of deciding who cars should kill, but that's not what's holding them back. When we think of self-driving cars, it's easy to forget quite how much we as humans actually do when we're driving. So the future of autonomous vehicles not only relies on navigating difficult roads, but also reacting to new situations, and now potentially passing a government driving test. And I don't know many humans who passed their test first time.
Zoe there. Now, when it comes to the future of transport, sustainability is key, and that's not just on the ground. Up in the skies, the race is on to decarbonise aviation. Companies are looking at different ways to be able to make air travel more environmentally friendly. And Mark Chislak's been looking at some of the more dramatic solutions.
Here's the problem.
The environment. We as a species are negatively impacting it in lots of different ways. Aviation contributes to just over 2% of global emissions. Pre-pandemic, that number was predicted to rise fast.
The problem with aeroplanes are those, and the fuel that they run on pollutes the environment when it's made and when it's used. So engineers, scientists and aerospace companies are looking at ways of cleaning up the stuff that comes out of those.
If we're going to allow people to keep on travelling, then we're going to have to make aircraft which are far more efficient. And so there'll be a real pressure to develop technologies, new shapes of aircraft, new propulsion systems that fundamentally reduce the fuel burn of aircraft.
Here at the University of Cambridge's Whittle Laboratory, they specialise in work relating to turbo machinery. There are several projects and technologies being developed here that are considering sustainability and new methods of powering aircraft. There's a wide variety of different projects underway, encompassing different kinds of aircraft, from new engines and components for big commercial airliners to projects like this one, testing out the efficiency of distributing lots of electrically powered propellers across an aircraft's wing.
So one of the advantages of electric propulsion is that rather than having one or two large jet engines, you could have many smaller electric motors powering the aircraft, and they have a very similar efficiency whether they're very small or very large. So we might see aircraft with maybe a dozen propellers in front of them, and that allows us to design smaller wings and more efficient wings.
Solutions like this have potential for smaller, lower range aircraft, but for bigger aeroplanes with longer range, the look and design of the outside and inside of these airliners that we're all familiar with could change, leading us to designs like this one, the blended wing. Concepts like this offer big advantages in terms of saving fuel due to the aircraft's shape, generating large amounts of lift. They also reduce noise as a result of the engines being mounted above the wing. And more recently, there are blended wing concepts exploring hydrogen as a fuel source that produces zero harmful emissions.
But these radical designs, like the blended wing, come with their own issues.
The technology is very important, but it's getting the infrastructure to go with that technology. It would radically change on the airport level as well. It would change the fuel. That implies an entire infrastructure to bring that fuel into the airport as well.
They'll also do away with windows for passengers. The wing blending into the cabin means you just can't have them. Instead, there's a suggestion that passengers will have virtual screens, which should make up for the lack of a real view.
Well, that's where hybrid technologies come in. Aircraft which look like a conventional airliner with gas turbine engines on the wings, but with an additional electric fan behind the tail. This is a concept known as boundary layer ingestion.
Now, boundary layer ingestion is a technology which is aimed at taking the flow that forms over the surface of an aircraft. The flow that's on the surface is what usually forms the wake behind an aircraft and causes the drag. The idea we have is to have a fan that's wrapped around the back of the fuselage, and so it ingests all of this parasitic flow at the back of the aircraft and takes that in and re-energizes it and turns it into useful thrust.
Time is the enemy here, though. Aerospace is traditionally a very conservative industry. Can a significant amount of research and development occur in time to address the world's urgent climate issues?
So if we're going to decarbonise aviation by 2050, then we need to get down to 1980s levels of emissions by 2030. So if you're looking at radically new concepts, you need to be able to work in a hardware-rich environment. You need to be able to build and test a lot of things, because many of those ideas are going to fail.
Here in Bedfordshire, Blue Bear Systems specialise in building UAVs for commercial and military use. They're leading a consortium including engineers from Cambridge in designing a propulsion system for a small zero-emissions aircraft. The project, called Inception, is part funded by the UK government. Blue Bear are now testing using flying scale drones.
This is going to produce a full-size working project in 2 years, but hopefully by 2030 there will be electric aircraft which people can pay to buy a ticket and fly around on.
In the future, commercial aircraft will undoubtedly be more environmentally friendly, but we as individuals will also need to address the impact of and the amount of flying that we all make.
Hello and welcome to the Week in Tech. It was the week the UK government announced the creation of a central NHS digital database will be delayed by 2 months due to privacy concerns. Jeff Bezos said in an Instagram post he will fly aboard Blue Origin's first human flight to space in July, though Virgin Galactic's Richard Branson is aiming to get there first. And Apple paid millions to a woman after authorised repair workers leaked explicit photos from her iPhone online. A massive internet outage brought down major websites around the world. Cloud computing provider Fastly reported widespread failure, which affected a number of high-profile websites, including Amazon, Reddit and Twitch. The downtime lasted for an hour and led to questioning the wisdom of having large parts of internet infrastructure in the hands of a few companies. Google was fined $270 million in France for unfair advertising practices. The penalty comes as the tech giant faces multiple US suits over anti-competitive behaviour and preferential treatment. And finally, meet the robot that might beat you at parkour. Researchers at Massachusetts Institute of Technology, that's MIT, designed a new humanoid robot which can handle the constraints associated with highly dynamic movements. The robot should be able to perform acrobatic behaviours, including backflips, front flips and spinning jumps. Yes, that's what happens if you leave your computer running.
For many, many years, there have been 4 modes of transportation moving humans around the globe: planes, trains, automobiles, and boats. But now there might be another one coming into the mix. Outside of Las Vegas, in the desert of Nevada, is the Virgin Hyperloop. This is a pod-based travel system that the company hopes will be the future of mass transit. The idea for this kind of travel was proposed in 2013 by Tesla and SpaceX boss Elon Musk. The idea is quite simple. Put people in a pod, put that pod in a tube, and shoot that pod down the tube at the speed of an aircraft. And that's exactly what the Virgin Hyperloop is working on making reality.
It goes directly to your destination, doesn't stop at every place along the way. It does that electrically, autonomously, and it does it inside of a tube.
Click visited this spot in 2016, and frankly, there wasn't much of anything to look at.
It just sounds so radical, so groundbreaking. It's hard to imagine it ever happening.
But in the few years since, they've come quite a long way. And in November of last year, they successfully completed their first passenger test. They traveled 500 meters in 15 seconds, going as fast as 107 miles per hour.
Yes! Yes!
Josh was on board for the maiden voyage.
It was absolutely incredible. It was like surreal to be sitting inside of a Hyperloop, and the ride itself, like you felt a little bit of acceleration, sort of like you would have in a sports car.
So this is just a beta version of the pod. The final one is expected to be a lot bigger, think the size of a bus, but also a lot easier to get into. The full-size pod is expected to fit around 25 people, but more importantly than that, it's going to house all of the tech that makes this Hyperloop system work. Now that's important because if something breaks or goes wrong, all they have to do is remove the pod and fix it somewhere else instead of going into the tube and potentially disrupting a lot of travel. One of the key components of Hyperloop travel is the ability to go really, really fast. So they designed a way for the pods to levitate using opposing magnets, which in theory will help it go as fast as an airplane. The pods will travel in tubes about this size and should be able to reach speeds of up to 670 miles per hour. That's fast enough to get you from London to Paris in under half an hour. The system of tubes can be built on land, over water, or underground, and maybe, just maybe one day across oceans. But building an entirely new infrastructure across a city or a country will take a lot of work and a lot of money. But Virgin's Hyperloop system isn't the only one being developed. Underneath the streets of Las Vegas is another Hyperloop tunnel, this one by the Boring Company. Yes, the one owned by Elon Musk. His system will essentially be an underground motorway. Old TV shows and movies may have led us to believe the future of transportation would include flying cars, but maybe the modern day version of that is actually a pod flying through a tube.
That was Cody. Now, electric vehicles are becoming commonplace on many roads, but the problem is you've got to charge them, and it's not always as simple as we'd like it to be. So how about putting down the lead and opting for a spot of wireless charging, courtesy of the road? Just think of it as being like putting your mobile phone on a wireless charger. The aim for this taxi isn't to be fully recharged, but just to get a bit of a boost whilst it's waiting at a taxi rank without any passengers. But maybe we're missing something here. Why worry about recharging the batteries when we could just be swapping them? Stephen Beckett's been to Taiwan to look at some other ways that electric vehicles could be kept powered.
This is Taipei's famous, or perhaps infamous, scooter waterfall. It's one of the main routes into central Taipei for thousands of commuters every day.
It is mind-boggling how many mopeds there are here. Thousands of them, they just keep on coming. And you know what, you really get a sense of just how much pollution that these guys are probably causing.
This is the same spot a few weeks later, and believe it or not, a good chunk of those bikes aren't producing any pollution at all. This is a publicity stunt for Gogoro, a Taiwanese startup that's pioneering the uptake of electric scooters in Taiwan.
Everybody's moving into cities and living on top of each other. And the need for adopting electric transportation as a cleaner mode of transportation. But here comes the problem, chicken and egg, right? Without the proper infrastructure, nobody would ever adopt a mobility solution that is electric, because charging in these big cities are next to impossible.
And this is Gogoro's solution to that problem. Riders own special electric bikes, but not the batteries inside them. Instead, when they're running low on power, they just visit a station like this to swap out their flat battery and pick up a fully charged one. A subscription of around $10 to $30 a month gives you access to any of the 1,400 swap stations around Taiwan. Gogoro estimate that their customers have saved 80,000 tonnes of CO2 between them. That's roughly 25,000 across the world flights. Over in San Francisco, one company has a different take on the battery swapping business. These are drive-in swapping stations from startup Ampul. You just park up, and within minutes a series of robots automatically remove the empty batteries from your vehicle and swap in fresh ones. It's an idea that's also being championed by Chinese electric vehicle maker NIO. They plan to build 500 stations across China this year. At the moment, Ampul's system can swap batteries into compatible electric vehicles in under 10 minutes. By the end of the year, they say that'll be down to just 5. Quite a big difference from the hours it can take to fully charge an installed battery. Each charging bay is about the size of a couple of parking spaces. At the moment, there are 5 in and around San Francisco, with plans for more soon.
The cities is a very tough problem. The grids there are not set up to deliver a tremendous amount of charge, and so putting fast chargers can be a challenge. One thing that we do is, because we can actually have the ability to slow charge the batteries, and we can choose when we charge it, because we separate charging the batteries from putting them into the car, we can actually use renewable energy.
The hope is the idea could initially be a hit with ride-sharing and last-minute delivery fleets who need to recharge quickly and get back on the road.
If you are a ride-sharing driver, you might be spending 10 to 12 hours a week at a charging station waiting for your car to charge and earning a lot less money.
Whether or not Ampul can convince owners and vehicle manufacturers to adopt their take on the tech, battery swapping like this could play a key role in solving some of the issues hampering the uptake of electric vehicles.
But we can't talk about the future of transport without mentioning flying cars. The question is, are they ready to take off yet? Nick Queck's been finding out.
Over the years, we've seen passenger drone demos, hoverboards and jet wings. One manufacturer from the Netherlands, though, thinks it's finally cracked it. Well, almost.
And here it is, the PAL V Liberty on British soil. Should we take it for a spin? Let's go.
Sadly, this precise model in the UK is unable to fly. It's had its parts decommissioned. But across the North Sea, I'm assured it does this.
Like you'd find in most aircraft, you've got the throttle here to control the power to the engines, the joystick between my leg, which controls direction, so if I want to go left or right or forward and back, and the pedals, which were used for driving, now control the rudder for yaw and can carry enough fuel to fly for up to 3 hours.
Of course, on the aviation frontier, safety is a work in progress. German outfit Lilium's all-electric prototype went up in flames early last year, around a month after another jet from Israeli startup Eviation caught fire during testing. Meanwhile, Boeing has pressed pause on its innovation unit Next. Backed by Uber and Toyota, Joby Aviation plans on bringing a flying taxi service to our airways. Other established car companies are piling in too. General Motors has unveiled a flying Cadillac concept, and with funding from Innovate UK and Hyundai, Coventry is set to receive a pop-up style airport for the flying vehicles of tomorrow. But time is of the essence. PAL V has been going for over 2 decades, but last summer received road certification, one of the very few in the world to do so. It's now working on air certification, and it's promising customers keys as early as next year. Similar solutions are being touted by its rivals, or as PAL V sees them, welcome competition.
That's it for our Future of Transport special. As ever, you can keep up with the team on social media. Find us on YouTube, Instagram, Facebook and Twitter at BBC Click. Thank you for watching, and we'll be back next week. Bye-bye.